Welcome to our panel discussion this afternoon. Thank you for joining us after lunch. My name is Dwain Rogers, and I'll be moderating this afternoon's panel on resiliency in this new electric grid that you've been hearing so much about throughout this entire conference. I think the buzzwords really have been resiliency, reliability, and the reality of a new grid, a grid where we've moved from a centralized generation, transmission, substation, distribution, transformer, end user, a one-way street, to a multi-directional, multi-nodal system where you have a lot of new assets that are intermittent or distributed, and a lot of new technologies that will allow for multimodal communication between these assets. And this has created a whole new environment. And so how do you recognize the opportunities but mitigate the challenges of this new environment? And we'll be talking about that in detail today with our great panel. So again, I'm Dwain Rogers. I'm the Executive Director of CleanTX. CleanTX is a Texas-based, as you catch from the name, organization. It's a trade organization with about 250 companies in the clean tech space. We were happy to celebrate our 10th year in 2016. With me, I'm going to go from sort of down the side from, I guess, your right to your left. Vonnie Smith, Vice President of Asset Performance Product Marketing at Bentley Systems. Bert Haskell, the Chief Technology Officer of Pecan Inc., and David McGeown, a principal with McGeown Associates. So what I want to do before we get into the questions is give each panelist just 2 or 3 minutes to tell a little bit about themselves and about their organization. So let's start with you, Vonnie.
Hi, I'm Vonnie, and I started my career right here in Austin at the University of Texas, studying electrical engineering and power systems engineering. And now with Bentley, I focus really on the full life cycle of assets. Bentley is a company that really is all about infrastructure assets. So whether it's road or rail or power plants or oil and gas or refinery or electric T&D networks, that's the business that we're in. We really work across the full life cycle of those assets. So from the difficult problems associated with the mega projects that are required to get these assets built and installed and conceptualized, all the way through to the operation of the assets. So we really get to experience a lot of the problems and have an opportunity to contribute to a lot of the solutions.
Great, and Bert, go ahead.
Yes, so I'm Bert Haskell. I work at Pecan Street, and I've been in Austin since '89. I came here to work in high tech, so I was in microelectronics and system development for a long time. And in 2007, I got into renewable energy and distributed systems. Went to work for Heliovolt in manufacturing, so we're doing thin film. And then in 2010, I came to Pecan Street. And I'm really interested in all kinds of distributed infrastructure. And Pecan Street's a great place to work on that. We focus very much on residential energy and water technologies. We started out monitoring Central Texas homes with high-resolution energy monitoring systems. So today we have the world's largest residential energy database. And in the process of accumulating that, we became very good at developing IoT systems, sensor systems, collecting the data from them through different modes of communication, getting that big data into a database and then doing analytics on it, and then delivering those analytics back in the form of products that are suggested by the data, mobile apps, control systems, things like that can be used to harness that data and turn it into something valuable for the homeowner. So that's kind of what we do.
Good afternoon, I'm David McGeown. Some of you will have seen me in other guises, so I do have to be a formal disclosure. I am not in any way in this session representing the federal government, although it is a major client of theirs. I've taken that hat off for the afternoon to be able to talk about other things, because I come from a technology background. That's what I do not come from Austin. I forgot to give that preamble. But that's what brought me to North America with technologies applied to buildings and then to the electric company. So some of the things I'll be talking about will be experiences I had as a chair of a global technology task force for a multi-billion-dollar global electric company, AES, and some of the minutiae we got into in New Jersey with PSEG with customers. So my primary focus as I look at this right now is the customer. I've enjoyed listening to some of the comments I hadn't ever heard until I came to ETS and forward-thinking utility CEOs, that I am the caricature so I can use it. The 50-something male PE that's been in the electric industry taught that they are always right and not to step out of the box doesn't necessarily have the right kind of feel for a customer. I got out of that a few years ago and have been very honored to do an awful lot of this in the Caribbean, where you want a different perspective. Talk to some of our customers in Belize, where it's not what kind of reliability it is. Can I have some electricity, please?
Absolutely. I think you can see we have a fantastic panel, and really what we've already heard, to me, when you talk about designing for reliability and resilience and mitigating some of the challenges of these new assets, you see it in this panel, and what you see is the ability not just to take a look at the technology, not just at the new assets themselves, but also at sort of the systems thinking approach, and how can we make these different pieces work together in a way where the sum is greater the whole is greater than the sum of the parts instead of the other direction around, which can also be the challenge. So we'll have a couple of questions that are sort of aimed, at each of the panelists, and then we'll have a few general ones, and then get to audience participation questions at the end. But let me start with you, Vonnie. So we've talked a little bit about this already, but how do you turn the current challenges facing utilities and prosumers into opportunities? How can process and technology help organizations to deal with the increasing security and safety challenges they face in this new environment that probably is unfamiliar and even a little scary to some utility and even regulator type clients?
Yeah, so as we've all been talking about over the last few days, this is a period of huge disruptive change for the utility, for industrial users and prosumers, not necessarily just the traditional utility, as they deal with the market reform changes, the decentralization that's happening, renewable energy that is just not the same kind of deal that they were dealing with 20 years ago. So the changes are really broad and significant. And one of the things that's leading to, from a challenges perspective, are these areas of reliability and resiliency. I was recently looking at a survey, last year's survey from Black & Veatch, and they surveyed really worldwide utilities and producers and consumers of electric power. And I believe it was about 65% of those people surveyed said that reliability and resiliency was their top problem. That was the top thing that they were concerned about. And I think it ties closely to their renewed experience with, or their hoped for relationship with the new consumer and getting closer to the customer. And it, of course, as we all think about it, it ties to the social contracts and the way that it's really an expectation that they're going to provide continuity of service. So paired with that, though, we also have an increasingly digital world that these utilities have created for themselves. For the last 5 years, 8 years, whatever, there has been an increasing investment in IoT data, and most of that was driven out of AMR and smart meters. But at this point, and I was at a conference probably 3 or 4 years ago where the presenter was talking about the fact that really they were only using a very small percentage of that information that was coming out of the smart grid. But I think now, as we see, as we overlay that with the significant power quality challenges and interconnectivity and new kinds of devices on the network, that they really are looking very closely at that information that's out there, and how can they leverage that IoT data that is available on the grid in order to solve these new kinds of problems that are really popping up as the thing that's keeping them awake at night. So I think that's at least one example of a challenge that's leading to an opportunity as they see the opportunity being really leveraging that information.
Fantastic. Yeah, full disclaimer, I am a proud member of Gen X, and so Raiders was a formative experience for me. But one of the things I always talked about with regard to information coming out of the smart grid or IoT devices is, you remember the last scene of Raiders where they put the Ark of the Covenant in the huge warehouse and they're like top men and you know you're never going to see it again? Sometimes it felt like previously some of the information coming out of the smart grid was going into that Raiders of the Lost Ark warehouse, and I think that's no longer the case. I think it is being utilized and used more effectively and more efficiently. And I guess to that end, Bert, tell us a little bit about Pecan Street's research into the consumer interactions. You know, Pecan Street has this incredible, almost not really a microgrid, but a neighborhood with all these devices. They're all being monitored. They're all being observed. And we're really seeing what the new energy internet or the new grid is going to look like. So tell us about what the research is showing. What are the real-world insights that you're getting out of that data, and where does it point us for the future?
Sure. Well, you know, there's a lot of information obviously there, and there's a lot of lifestyle things. There's a lot of opportunities for products that are being revealed. I think the most relevant in terms of how customers will interact with the grid, if we're looking at it from that perspective, and how utilities want to deal with that, because there's certainly a lot of information beyond what the utility itself would use. But you know, one of the things we noticed initially is when we provided people with really high resolution data, there's probably a limited period of time where they're interested in that. Once they look at it and draw some conclusions, you know, it's not that big a deal. So what's the real application for high resolution energy data and collecting it? And it's probably more machine to machine related. So one area is diagnostics. If you can watch a high resolution energy signal and diagnose different systems in the home, that's really important. We do that with water as well. If you can watch the water signal and tell if somebody has a leak, you can avoid a lot of property damage, or you can avoid a huge water bill if the leak is underground and otherwise undetectable. So the opportunity is to figure out how to get access to that data in a low-cost fashion. That's where IoT is helpful. But then once you have access to that data, how do you do something automatically? The other thing we're seeing, like with distributed energy, is people are really interested, obviously, in solar. They're interested in batteries. They're really interested in electric transportation because they're actually becoming cheaper. It's becoming cheaper to own an electric vehicle if you drive within the range of that vehicle, because charging it is a lot cheaper than putting gas in the tank on a per mile basis. So people are really interested in that, but the way they articulate their energy goals tends to be things like, you know, I want to minimize my energy bill, or I want to keep all of my solar because the utility is no longer giving me a rebate, or I want to use my solar to charge my electric vehicle because I want to minimize my EV costs. So how do you take high-level desires and statements like that, allow the person to prioritize them, and then have a control system that executes on that? No one wants to go in and actually decide when the vehicle needs to charge, or actually when to run their air conditioner. So we have to get past that. So the ultimate consumer for all this data is another machine that's going to figure something out useful. And that's where we're kind of focused now. How do we turn those high-level expressions of what is wanted into a control system that delivers that objective?
I think that's excellent. I mean, I remember one of the other thought leaders here at ETS is Rayford Smith, who's with Entergy, and I remember when I worked with him previously, he would often say that, you know, when I'm in the utility space, if you're talking about sort of your typical middle-class customer, I'm 3% of their wallet every month. And so I'm just not going to be top of mind for them. Their phone bill is much higher. You know, what they pay to consume internet is much higher. The utility bill, it would be nice to get it lower, but how much work are they really going to put into it? So I agree that sort of automation, that sort of machine to machine is critical. So David, how do you see the relationship with customers changing as all this technology is deployed? You know, what are the customers going to do that we don't expect, and where is this going to take us, both from the standpoint of utilities and from the standpoint of service providers?
Gut, das Frage ist sehr einfach. Gibt es hier jemand, das versteht mich? Twice. I made that enormous mistake of opening in an energy seminar at Fort Bliss in Texas where that division had just come back from 3 years in Germany, and every single soldier and officer put their hand up. And yes, I said that it was an easy question, does anybody understand me? And my point there is that having been privileged to be in customer service in and around utilities a few times, I think that we fundamentally have the relationship wrong. And I heard that both from, and I really don't believe it, and sorry man, I'm insulting all of us, that it's a coincidence that the two most forward-leading customer service passionate panels we've seen were both ladies as CEOs in the past 24 hours. And I've experienced it directly myself in customer marketing inside utilities. So, quick poll. How many of you representing the customers believe energy is important? Not many for this audience. All right, my position, wrong. Other than on 2 occasions. And from a marketing perspective, they really suck. Because my experience is customers care about us on the 2 occasions when they are, using the vernacular, pissed. It's because the bill's $1 more than they expected to pay, or because we're not there. The rest of the time, we're just in the background. So my answer is that as I see all these technologies deployed, I'm actually excited. Those little yellow things yesterday, I was one of the one-word people that said excitement. As I see the true opportunity to truly transform the vision of this business from me to Bert. Bert showed up on the floor of most traditional utilities somebody would be calling security. But, you know, that's the thing yesterday about creativity. We're trained to be in our box. We're trained to be in our cube. And I saw really, really good people in the utility I worked with in their 50s had given up being creative because the moment they stepped out of their box, oh, you're not supposed to be doing that. We've got to go back to regulator. We've got to figure all that out. So as I see all this technology deployment, I love this. I love the creativity. I love what the millennials are saying to me because they're saying I'm nuts. I've got no idea. So if, as an example, in the Virgin Islands, as we're looking at deploying new stuff, I'm really concerned about the older population. We have a focus group and the older population, oh, don't worry about that. My granddaughter take care of that. Because they're sitting there with the iPads and that stuff. So the transformation I see with all this technology is the ability to turn that around. And with these new products and services that Bert and all the creative minds are going to design for us, all those great applications that push. You don't have to pull all the information out for it. They give me useful information about my quality of life. And you follow me around the Caribbean, people don't care about energy, they care about their quality of life. Right now, energy severely negatively impacts their quality of life. So any of the products we bring to them are great quality of life enhancers. We kind of take it for granted a little bit, but if you look at all the opportunities that are out there, I see that as the 30-somethings, and I really wish there were more in utilities, but we've not encouraged them that much. It's not really the most exciting career. We're suffering right now from all the loss of kids coming through with STEM education. That's really going to severely impact this, because you can have all the creative minds, but somebody's still got to go up the pole and pull the lines and do that kind of stuff. But I see an excitement about all of these new products and services can be out there that enable us to do better things with our quality of life. And maybe it's a bit of a stretch, but maybe a utility could have an Apple-like relationship, because do people care if the light's out for 5 minutes? Probably not. If my iPad's not working, my world has ended. So that's where I see it going.
Well, so the commercial 10 minutes after the internet goes down and the lady's trying to swipe the picture saying it won't swipe, it won't swipe. I've experienced that. We recently moved, didn't have Wi-Fi for about 2 weeks, and my 5-year-old was way up in my business saying, Daddy, the iPad does not work. This is not good. But it's really true, and I think that what you say about utilities, I remember some folks who worked at a utility that will remain nameless, they said, we understand that our business model is changing, and we understand that that's a reality. But we don't know really what it's going to look like, and I'm not saying we want to be the last ones to adopt it, but we're more than happy to be second to last to do so. So I think nonetheless, in many ways, we are seeing this change is happening, and sort of in some ways the floor is being swept out from underneath us, but on the other hand, I think we have a great chance to land on our feet. So we'll move to a few questions now. They're really kind of aimed at everybody, so just kind of a grab bag. But you know, again, we've talked about resiliency, reliability, mitigation, and design. How do you design, how do you bake into this new energy internet or this new network that's replacing the grid those elements to take account of these new assets, these new technologies? So maybe we can just go down each and one of you, what is the biggest opportunity and what is the biggest challenge that you see?
Well, I think from an opportunity perspective, I mean, one of the things that we're working on at my company, again, is the full life cycle. So, we're helping people when they're conceptualizing a new transmission line or when they're thinking about, the assets that are going to be necessary to drive a network to provide energy, electricity to the end user. And so, we believe that a lot of that work can be enhanced by thinking about the reliability up front, thinking about the reliability and the resiliency in this sort of challenging environment. And so, what that means is to understand the way that assets are going to fail, to be able to predict the way that assets are going to fail, to be able to think about what that's going to mean to your resiliency. How, if you lose a piece of high voltage equipment, how can you think about at the very beginning that you want to be able to bring that on quickly, you want to be able to restore service quickly. So I think there are some opportunities there that are really important that are about, sort of the beginning of the life cycle, thinking about how that asset is going to perform all the way across the life cycle. I think one of the other things to think about that tie those two together is this idea that's talked about frequently called the digital twin. And so the digital twin is really about when you design an asset, when you conceptualize it, you really start thinking about it at the very beginning, that you gather up all of the relevant information about that asset. And some of that can be, some of the really cool reality-based data that, really describes how this asset fits into the real world. And to bring that along with all the design information, the 3D design, the really detailed kind of characteristic of that design, to bring that all the way forward so that when you're operating that piece of equipment, that you can go back and you can understand how that piece of equipment was designed. Virtually, you can walk through that piece of equipment as you try to understand why it might be failing or how it might be failing. And so I think it's those kinds of technologies that are going to flow all the way through the life cycle that potentially can kind of be a game changer as you get to the end and you're trying to deal with those resiliency issues.
We're looking a lot at resiliency, and that's kind of what drives a lot of the demand. A lot of people, if someone's never lived through a power outage, then they're not as interested in having a backup generator. If somebody hasn't had, the ceiling of their living room destroyed by an overflowing water heater in the attic, then they're not as interested in leak detection. These things only become important when you've lived through it and realize, how disruptive the interruption of these basic services can be to your life. So when you think about just societal resilience in general, and how do you make it so that 90% of your population can go about their daily lives if there's a nuclear plant has to be shut down. That's Japanese are working on that now. How are they replacing all that generation without disrupting their total economy and total society? I think one of the big opportunities is for every society or every community to not only look at how can they make their energy systems more resilient, but how can they supply everything needed to keep that energy system running with their local economy. How do they not have to go outside of their community for most of the things that are required? That includes the technology components, that includes the wires, that includes the labor to do all the installation, that includes the consultants to do all the data analytics. How do you do that yourself? That's what we're trying to do at Pecan Street, and that's what we're trying to teach other communities to do. We don't want to do it for them. We just want to show them how to do it. And and that's what we're focused on. How do we come up with those? Resiliency is really about being self-contained and able to fix your own stuff when it breaks. And so that's one aspect of it. The other one is how do you get the community or the residential customer to partner with the utility in resiliency? The utility has to have so many 99.999 9 uptime. And each one of those 9s, I don't know what the ratio is, but maybe it increases your cost by 50% every time you add a 9. So if the customer can have their own microgrid that functions 90% of the time, then maybe you can remove one of your 9s and give it to the customer. And by the way, now that customer is not totally dependent on you. And so that changes the relationship. Now they don't get pissed off because they're not totally dependent on you. You're not that monopoly supplier of a service. So how do we negotiate that? How do customers want to control their own destiny, but then the utility can also provide a great service. So.
Fantastic. Farm to table in the energy context. David.
So I'm with my new brother here, Bert, because so much of what he's saying resonates. I actually have had some quite depth experience in prognostic software. Isn't that a good word to use, prognostics? But having come from so much of the buildings industry, one of the favorite things we'd have over a few beers is heard the phrase, you're only as good as your last bad job. So that I think that's what resonates with your issue. So just as an example of the issue where I think we've got the value proposition wrong, a couple of the CEOs have mentioned that charging for a kilowatt hour is about as wrong as you can get. Our customers don't care about kilowatt hour. Anybody here in the past month checked the speed of their Wi-Fi connection from the local cable company? Have you checked whether or not you've really got a 3 kW connection with 5.9 reliability from your utility? No, but dang it, we all know pretty quickly if the cable company is not providing 50 megabits per second up and down. And we ran a survey a little while ago looking at costs of energy. Anybody idea, roughly, most expensive form of energy in the world? Price per kilowatt hour? No, numbers, dollars per kilowatt hour. Just throw something out. Come on, I'm going to have some fun. Go ahead.
45 cents from diesel?
Not close. Think about it. Energy, I said. Electrical energy. Anyone go higher than 45 cents? I'll give you an example. Last year in the Virgin Islands, we hit 55 cents a kilowatt hour. Not even close. It wouldn't even show on the chart.
Well, if you're in the Arctic station, you've got to build.
Yeah, there's a few there that run $400 and $500 a kilowatt hour. For time's sake, I'll help you. Anyone getting closer? I want my watch to work. I want it reliable. You know how much I calculated I paid for the electricity in my watch? About $3,700 per kilowatt hour. I was talking to a lady that was charging up her cell phone. I've got my $55 little charger there. I don't know how many microamp hours I shoved in my phone at lunchtime. But often the point of that is about the facility of wanting to need it and not go through that. So I'm all over Bert's value proposition. But it's about getting that creativity stuff. When you haven't got it, as I did for post-Katrina, I'm currently about $4,500 for maybe 10 kilowatt hours for the generator that's now connected to my house. It arrived on day 10. We got power back on day 9. Those are the kind of things that drive people to make those kind of decisions. But when I think about this in terms of the reliability and changing value proposition, any aviation nuts here know who One Trip is? No, C.R. Smith? Dang, sometimes I get one or two. One Trip founded Pan Am. C.R. Smith founded American Airlines. The two of them realized in the 20s that we had fundamental wrong value propositions. We were coming out of the railroad industry. Railroad sound like a utility, was paid to deploy as much capital as it could on the ground, called tracks, which is why we've got windy tracks all over the place. But they came to the marketplace realizing our customers don't care how many miles of track we've laid. They care about transportation. How effectively can I get from A to B? So One Trip and C.R. Smith, One Trip helped design a wonderful airplane called the DC-3. DC-3 got most of the US through transportation in World War II. Beautiful airplane. I think, yeah, and C.R. Smith helped with the Boeing Stratofortress, one of the first early big airliners. So it's about thinking through what it is that you want. And for us, I think we're going to see lots of these creative ideas about the relationship with the customer changing in terms of reliability. I have automatically eliminated myself with my opening statements. A 50-something PE professional engineering male, probably not creative enough. But I don't know where all these ideas are going to come from, but lots of them are going to come out, and it's going to be about the Internet of Things and how do I ensure my stuff works, because it needs electricity. That's where I think the exciting piece of it's going to come.
I think we'll do one more question for the panel and then turn it over to questions for the audience. For this one, I want to do a little bit of a setup with an example. This example is probably a couple of years out of date now, but I remember in Southern California they were looking at the reality of a number of EVs per transformer that was becoming a concern for the utility. So the example was they decided, okay, let's say I've got a transformer serving 4 houses. 3 of those houses has an EV. If all 3 of those EVs charge at the same time, I'm going to blow my transformer. So traditional response, upgrade transformer. Do that for all your transformers. Way too expensive. So instead, the solution was a little bit of a softer, more of an algorithm-based solution that said, let's say that each of our panelists has an EV, Vonnie's at 10%, Bert's at 50%, and David's at 90% state of charge. Every 5 minutes, we're going to check again, and okay, Vonnie, you're at 10%, you get all the ZOTs for the next 5 minutes, and then we'll go from there and we'll reevaluate every 5 minutes. And that way you're using whatever headroom that transformer has without replacement, and you're eventually getting to a state of charge of 100% for everybody.
Which coincidentally you may not know it, but having had an internet company, which is exactly what many of the internet companies to do to fill the bandwidth on the pipe to your house, and you will never notice.
Exactly. And so I guess that's my question is, on the one hand, as you look at these new assets, at IoT, at devices on the edge, at all these new possibilities and distributed resources, one solution would be strictly technology infrastructure upgrades. Another possibility, or other possibilities, is to use algorithms and controls and more of a software, if you will, approach. Where do you think that balance is, and where do you think the sweet spot is for the industry?
Well, I think it's a good question, and I think it's a difficult question. So if you look at utilities, for example, and you compare them to other industries, like in some ways there are, from a technology standpoint, in some ways they're ahead of other industries. If you look at the amount of digital data that they already have describing operation of their infrastructure, you might say that they're somewhat ahead. Compared to industrial use cases or process manufacturing or chemical manufacturing, who are at the same time looking at automation, looking at IoT as being a major driver to get where they want to go. So I think they're, in some ways they're ahead. In some ways they're behind. I mean, if you take another area of process and technology like change management and configuration management, for example, which is a big part, in really sort of sensitive assets like nuclear plants, for example. I mean, there is a major investment in those kinds of assets, in standards and compliance around standards, reflecting, any time they had changes in the system, anytime the configuration changed, it kicked off certain things that needed to happen. So I think from a utilities perspective, they're going to have to continue to make those trade-offs every day. And they're going to have to be driven by what they need to accomplish, what their customer wants to have happen, and the relationship that they want to create there. So not an easy thing for them to decide, but certainly I think those trade-offs are going to be necessary.
So we, as far as the architecture of creating a more reliable grid, we're focused on the what goes on behind the meter. I guess that's a term. I'm hearing that less and less, but we're focused on that. And really, one approach to modernizing the grid is to come up with a very sophisticated, gold-plated distribution infrastructure, and that's expensive and that's inherently vulnerable. But if you have, each of your, let's say your residential or commercial customers have a lot of capability to respond, then you can have a much dumber grid as long as you publish information about what the status of that grid is, and they can respond. So we have an architecture right now where we deploy a low-cost retrofittable sensor to a transformer, which means you don't have to replace infrastructure. You just put some relatively low-cost IoT, and this device looks at the high side, it looks at the low side. It basically replaces the smart meters as well, because you don't have to measure the consumption at the homeowner's location if you're measuring it when it comes out of the transformer. So we've got, let's say, a very low cost, full monitoring of what's going on there. That system broadcasts to everybody connected to that transformer. Maybe it's 4 people with electric vehicles. And now those electric vehicles, they've got intelligent chargers, they've got smart inverters. You can ramp up the charging of my neighbor's EV if I'm overproducing solar and my car is not there. And so you can nip a lot of these problems in the bud at the transformer. And so you limit the amount of issues that get propagated up the feeder. And so that's how we're addressing it. We're trying to make the edge more intelligent and give the utility an easier problem and a less expensive problem to solve.
So for the sake of time, I go to, did you really ask me that in 2017? Are we going to go for hardware or apps and software? Now, I have no doubt that I'm probably not going to be a great part of the answer to all that because I don't know. But to me, it almost feels like we have had no choice, because in decisions made by, and sorry ladies, it has been men predominantly, our fathers and grandfathers on these systems were right for the technologies we had then. But the distribution systems and transmission systems we're going to have in 20 years are going to be nothing to do with any knowledge we have right now. It's going to be the kind of knowledge you're creating. And for me, the simplest way of answering that, you've mentioned it twice, is if anyone hasn't noticed what's happening in transportation, you're asleep at the wheel. There's a pun for you. And
Great local band, too.
It has to be the application to facilitate us not using somebody else's petroleum that's imported, although we're importing very little right now, but it moves to electric vehicles, and it's going to be about the software, not the infrastructure. We will be able to recover costs in the infrastructure, but I wouldn't stay back in the 1920s just because we've got a few $1 billion worth of infrastructure that's now stuck. We've got to move on.
Yeah, I would agree. I guess I would say that sometimes what I've noticed is that without any malice aforethought, the market structures and the regulatory structures that were designed for that older world you were talking about simply can't accommodate some of these new transaction types and new technologies, and that so to some degree, that's where a lot of work needs to occur. And with that, I think we have time for a couple of questions from the audience, so let's throw it out to you guys. Yes, sir. Or ma'am, I'm sorry, I don't have my glasses on. I'm so sorry.
So this is a question for Bert. I'm Margaret McCall. I work with the Rocky Mountain Institute. I am wondering, thinking about demand flexibility, how much have you been learning about essentially customers' revealed preferences rather than their expressed preferences for how flexible they're willing to be? I'm thinking specifically like a residential demand response air conditioning program. People might say, you can only mess with my AC twice a year. But then if you, maybe you're learning something that says they're actually willing to accommodate more frequent, more subtle adjustments.
Yeah, we've stayed away from too much air conditioning demand response work. We looked at it when we initially got into it. We weren't real keen on it because of those complaints, and since we interact with a community on whose cooperation our whole business and work depends, we have avoided projects that turn off their air conditioner. Now, Austin Energy reports that that's been a pretty successful way for them to get some demand response, and we know a lot of people have those smart thermostats installed. Some of them turn them off, some of them don't. The system they had in place didn't give that feedback. So what I'm trying to get at is here, we don't have a whole lot of data. What we do know, of course, is that even from day to day, people's preferences change. My wife sometimes is really hot, and sometimes she's really cold. And so, and she's turning it, and that doesn't, and then what I want to do at that point maybe doesn't matter so much. So I might, I'll go in another room or something. So, solving people's that level of at the end of the day, people just are going to figure that out themselves. It's even hard to predict when there's two people in the house. How's the nest going to know? If she wants it hotter and I want it colder, it can't resolve that. So we're skeptical of that. Now, what you see in the data though is we've learned that their EV charging is not that rigid, and that's a very flexible load. You need it charged. It needs to anticipate how far you're going to go, but you can vary that rate of charge and that charge level parameters a lot. And so how do you get people to articulate their preferences at a high level and then turn that into a control strategy? So I don't have any magical answers for you there, but what we've observed is that a lot of loads are more flexible, particularly EV charging. This is why batteries are so important, because it lets you do demand response without having to impact people's behavior. And so we're also focused a lot on batteries. And of course, the cost of batteries is coming down so fast now, 15% a year or more. And so at that rate, that solution is going to kind of neutralize the issue of when people want to actually use the energy.
We have time for one more question. Yes.
Thank you. Omid from Yoda Solar. So one question I haven't seen that's discussed is time of use rate structures. I feel like that would automatically help to the demand side equation, letting consumers control, hey, when do I want to charge things, when do I want to wash a machine? Why is it so difficult for that to be implemented anywhere outside of California?
Well, I'll take a swipe at time of use. California has really expensive energy, and so it seems like socially that's a somewhat acceptable, fair way to do that, and it does reflect the demand. I think ultimately, what you were saying earlier, kilowatt hours is a bad way. Even if it's dynamic, it's still not a great way to charge for electricity. Quality of service is really how you want to charge, and then that encourages the customer to upgrade their ability to interact with those charges. But I think it's mainly because of just the cost of electricity there is so high, and they've got such a potential crisis with their nuclear, phasing out their nuclear plants and things. And in the rest of the country, energy is just very, very cheap. So,
and having run a utility billing system, the answer I would give you is called MV90. It's the standard that goes into a billing system, and almost impossible to change stuff quickly. But that's in the old architecture, the old infrastructure. 10 years from now, it's going to be very close to real-time pricing in a lot of markets, I have no doubt.
Fantastic. Well, I think we are right about at time. Maybe one more? Let's do one more question. Thought I saw a hand up toward the back there. No?
Bar must be open.
Did I see it? I thought I saw it there. Yes, ma'am. Did you have a question?
I was just going to comment that ERCOT actually just created a report that said there were 836,000 time of use customers in the retail electric provider market in the ERCOT footprint. And those are varying rates of time of use. They can be robust programs and they can be block and index rates. But if they have any time varying piece, but 836,000 meters are on some form of time of use program.
And presumably that's a deal between the retail electric provider and the consumer themselves, yep. Right? That's sort of layered on top of the market structure of ERCOT, right?
Versus the political will of California.
Precisely. Yeah. All right, well, thank you so much to this great panel, and thank you all for attending, and enjoy the rest of ETS17.